Okay, as promised, here are the additional topics that I couldn't fit into my predicted paper 3. If you haven't seen that yet, then do go and check it out. It's really comprehensive, covers an awful lot of things that are super common and that haven't come up. But when I made that, I needed to make a decision on what to include and what not to include. And there were some things that I really wanted to put in and couldn't because of the restrictions of making it 80 marks. So this is like the overflow, if you like. So you can download these questions from the description, and we're going to crack on and work our way through. Another way is you could just hit pause, have a go at the question, press play, and then see the solution. So this is asking us to find the mean. To find the mean, we do the MAD method. That tells us to multiply, add, divide. So the first job is to multiply all of those. Now, remember, you have a calculator. Please use it. Biggest mistake I see is that. We don't want to do that. And the calculator will definitely ensure that we don't make that error. Once you've multiplied across, you will add that column up. And then the next biggest mistake I see is dividing by 5 or by how many rows there are. We want to divide by how many students there are, which is the total frequency. And we've got our mean. The second part is asking us to work out the probability that a student taken from the class won at least 2 medals last week. So we're going to go back to the table. At least 2 medals means that this group, and this group all count. 2 is at least 2. So we've got 8 plus 6 plus 3 equaling 17. So it's 17 out of 32. Okay, our next question is to write the nth term of a sequence. So the first thing that we do is look at the gaps. We can see that it's going up 4 each time. So that first number that you get from looking at the sequence is the one that you squash to the n. You then go backwards, go in the opposite direction, which means you'd be taking 4 off. That would take you to -3. And the last thing that you do is the last thing that joins or that you write to complete and finish that. So that is our nth term. Now, this is a strange one. We weren't overly tested on the fraction front in paper 1, which is incredibly unusual. And it may just mean that they're not doing that this year. It could mean that it's turning up in a show that style question. So it was worth just mentioning it. A lot of us are going to be thinking fractions, their non-calc won't see that. And then we're not thinking about those methods anymore. So it's probably worth just bearing that in mind. When they do a show that, basically it just means, yes, they've given you the answer, but you've still got to show all the maths that gets you there. So you can't just put that into your calculator. You've got to work it through using your methods. You do have the calculator to double check you're doing your maths right though, so please still use it for that. First thing is we're going to change into improper. So 2 times 5 is 10 plus 1 is 11. So we've got 11 over 2 divided by 8 twos are 16, 17, 18, 19 over 8. Then it's keep, change, flip. And then we just do it. Now you could half that, show a little bit of the cancelling process, and then it really will just equal the answer. And then, yeah, just use your calculator to make sure you haven't made any mistakes. So we've not seen a pressure force area question yet. This one's combined with a cylinder, so that it's using that skill as well. We've got to work out the volume of the cylinder by using the information about pressure, force, and area. Now, the first thing I want you to remember is this is actually a formula triangle. So you've got your pressure, force is on top of the fraction, so it's on top of the triangle. And that's quite a nice way so that then it doesn't really matter what part of the information they're giving you. They could give you any of these in the question. It's going to tell you what to do with them. So we've got the force and we've got our pressure. That's going to help us get the area. So we're going to be doing 68 divided by 1.8. And then from the formula sheet, we can see that the volume is the cross section, which is the area of our circle, times the length. We have already found the area of the circle. So we just take our answer, times it through by the length, which is 12. And you don't actually need to round at this stage. The 37.777 is on the calculator screen. So all you have to do is hit that times by 12. And then the final answer to 3 significant figures is 453. Okay, we've got a units question. They do quite like this. So the first thing you want to do is set it up 54 kilometers per hour. So per 1 hour. That's the same as saying 54,000 meters in 60 minutes. So you can see I'm starting to get the units that they want. I don't want minutes though, I want seconds. So there are 60 seconds in a minute. So I times that by 60. My meters are obviously staying the same. And then the calculator will tell me it's 15. Okay, our next question is about a purchase in the sales. Now, the temptation with this question is to perform an increase because we are trying to find that original price of the dress, but it will be wrong. Simple as that. It just will be wrong. You can't change the story from a decrease to an increase. We know that she buys the dress for £28.35 and it was discounted. So there's my decrease by 25%. 2-tick question means original times multiplier equals result. And like I say, you cannot deviate from the story. It is a decrease. So our multiplier will be 100, take 25, and then you divide through by the 100. So we've got 0.75. We don't know the original. We do know what she paid for it. So there was a cost that was decreased by this to equal 28.35. The original is what we're after. To finish it off, we can just pick it up and divide through. That gives us 37.8. Of course, it's money, so I'm going to put the extra 0 on. We want to work out how much Penny saved by buying the dress in the sale. So we're going to take off the sale price to get our final answer, £9.45. Okay, so this question is a scale drawing showing the position of 2 ports P and Q. We've been given the scale and we've been given some information about port R. It's on a bearing of 80 from port Q and on a bearing of 35 from port P. And what they would like us to do is find the real distance of port R from port Q. Now, in order to do this, we are going to need to see that pathway that port R is on from both of these ports in turn. So we're going to get our protractor and we are going to pop it on port Q to start off with. Okay, now you can see that I have positioned the north line is completely covered. That's where my 0 is, and my cross is at the center. I am going to measure around to the 80, and then I will mark that. Move my protractor out of the way, get my ruler. Now, what I want to do, get my point and my dash lined up. Once I'm happy with that, I'm going to draw this long line. Now, I don't know how long I need to make it. That's why I'm just drawing a long line. I know that the port I'm looking for is somewhere along this line. Now, I'm going to repeat that for the bearing of 35 from P. Wow, look at that. That virtually crosses it in the spot of the edge of the protractor. Now, the crossing point is where the port is. It's along this path somewhere, and then when it's along this path somewhere, and where they cross is the exact position of P. I've got to measure the real distance of port R from port Q, so from here. So I need to line my ruler up along here. And that's coming out at about 9.3. So my scale is 1 centimetre for every 40 kilometres. I've measured 9.3. So using that fact method, we're just going to times across, don't need to divide by the corner. So 9.3 times 40 gives us 372 kilometres. Okay, so we've been given a trapezium. We're told that BC is parallel to AD and that we need to find the largest angle. Now, we're not going to be able to work out the angles unless we know what X is. So that is ultimately the problem here. Now, I did a worded version of forming and solving in the predicted paper because we haven't seen one like that for a little while. So I thought it was worth a reminder. But these are more common, so it makes sense for us to include another one here. They're making a point of telling us the two lines are parallel. This is because we will be able to use co-interior. If they are parallel, that tells me that I have my co-interior angles here, which equal 180 degrees. So my equation is 7x plus 5x minus 12 equaling 180. That's what's going to enable me to find x. So I'm going to go on and solve. So tidying up the x's and kind of hopping this at the same time, landing as a positive 12, and then dividing through by that 12 to give me x equals 16. Now I need to put that 16 in to these x values so I can work them out. 5 times 16 take away 12. I can just throw that in my calculator and I've got 68. So I've got the first three and I'm going to mark them on the diagram. Now, this angle here, I can work out by doing 360, take away the ones that I know. That way I can check that number. Or I might notice that because this one is bigger than this one, it would mean that this one is smaller than this one. So I already know it's going to be 112. But if you don't see that, if you can't see that mass, don't risk it. Just do your 360, take away what you've got, and then you'll know it's 112 degrees. Okay, so we have to match these graphs to the table. It's really testing if we know the shape of our graphs, but you can use your calculator in order to help you here. It's a really, really good thing to know. If you know how to use the table function to put in these equations, then the table is going to give you a set of coordinates. You can then imagine these coordinates on the graph. If the coordinates are sitting on the lines, then you know you found your match. Sometimes you might get a coordinate like, let's say, 0, 0. And if you get 0, 0 and then look at these graphs, well, 0, 0 is on that one, it's on that one, and it's on that one. So just looking at that first coordinate wouldn't be enough to be able to eliminate all but one. And that's where, again, you would start to look. So if I then went to look at 1 and it was a negative coordinate, then it could fit on this one. But 1 and negative wouldn't fit. 1 and negative wouldn't fit. And now I found it. But if it was positive, I've still got 2 it could be. And so you have to keep kind of working with the coordinates to try and work out which one it might be. Now, it isn't foolproof. You're not really supposed to be using the calculator. They are testing whether or not you recognize visually your graphs, but it's a great way to prevent the guess if that is how you normally do it. So using that function is amazing. The answers to these, the first one, we've got an exponential graph, which is D. The next one is cubic. Now we've got 2 cubic graphs. This is cubic and this is cubic. This is x cubed, or most likely x cubed, because it's quite smooth as it goes through its bend. Whereas there's a lot more happening here with the bends being created and more exaggerated. And we've got a lot more happening in our equation. So A is that equation. And then we've got y equals 2x. Now, a single x creates straight lines. We've only got one with a straight line, so that is C. And our last one in this little mini revision session is our probability. Slightly different. So hopefully you're going to enjoy the problem solving side of this one. We've been told that he's going to go through 2 sets of traffic lights on his way to work, and the probability that he stops at the first red light is 0.3. So we can put that on. And we also know that this will be 0.7, as they must add to 1. It then says the probability of Roman stopping at both the first and the second red light is 0.072. So that is stopping at the first, stopping at the second, which we don't know, giving a result of 0.072. Now you always times across, so we're timesing to this number that we don't know. To get that number, we're just going to divide through by our 0.3. This gives us 0.24, which will enable us to then work out this needs to be 0.76. Gets repeated. We have completed our tree diagram. So I hope that little additional set of questions has been useful. Best of luck for that exam on Wednesday. And a massive thank you for letting us be a part of your revision and preparation for these GCSEs.